Hi, this is Anna Solovyov, and I'm going to talk about reflection, refraction, and total internal reflection as part of the optics topic of physics, where light is an electromagnetic wave interpreted as a ray model, so just a straight line rather than waves, like here, wave fronts. And I'm going to look at the aspects of light of reflecting, refracting, and totally internally reflecting. So one of each of these three cases of light striking material, and specifically a smooth interface between two optical materials, so like glass usually. So my example number one is very straightforward, using Snell's law, where the angle of theta through water, light coming through water, and is gonna reflect when it hits the glass, and the angle of reflection is gonna be exactly the same as the incidence angle, so it's just gonna be 60 degrees as given. But the angle of refraction can be found using Snell's law, where the index of reflection of air is just 1, and of glass has to be greater than the one of water for it to refract. And so it is. The glass is 1.5 and the water is 1.3, roughly speaking. So given the angle and the two indexes, we can find the angle of refraction, which is, in my case, 49.3. And as I already said, the angle of reflection is just 60, the same as the incidence angle. And to interpret this answer, I would just say that this explains why when we have a straw in a cup of water, let's see, that doesn't quite work, never mind. We can see the refracted image of it, so it's not quite straight, but it's slightly at an angle, just like here. And my next example is a total internal reflection, which is pretty straightforward, where we have a pipe and we want all the light to reflect back into the pipe, so we want to find the maximum angle. And using the similar law, but specifically for finding the critical angle, it's just going to be the fraction of the two indices. So in our case, it's a plastic, so it's 1.6 at the bottom and 1 of the air outside, so we can find the angle, the critical angle. But we're asked the maximum angle, which is just going to be from the normal, so it's going to be 90 minus a critical, 51.3. And so the real life application of this would be if you have a laser pointing inside a glass curly straw, the light is just gonna go inside the straw and come out from the end of the straw. And I realized I need to do a hard example, and I really like the first one from the homework because it has a bunch of geometry and angles, which is a little confusing but at the same time pretty interesting. So using Snell's law again, we had to find this angle, and we had to see the fact that the so the sine of theta of air was 50 using the Snell's law, and then we had to notice that this minus 30, which is the normal right here, of the normal, right, this one is going to give you 20, which is going to be on this side, and then 90 minus 30 minus 20. So looking at this normal angle here, if we subtract those two, we can find the one inside, which is not labeled here, which is 40, and then if we add that one with our 30, we can find 70. So this angle would be 70, and given that, well, this is symmetrical, so on the other side this one also is going to be 70, then we can find phi, which is going to be 180 minus 2 times 70, and it's going to be 40. And yep, that's it. I hope I was clear enough to get full points. Thank you.